Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing differentiation. This is part 2, where we shall be discussing stationary points. A curve has equation y equals x power 3 minus 12x. Find the coordinates of the turning points of the curve. So in the previous video, we said that differentiation is a very nice technique to obtain the gradient or the slope of a graph. And we are going to further extend this concept to understand the following property of curves. So if we have a curve that looks like this, we should understand that the gradient at these points is equal to 0, because if we draw a tangent line here, the tangent line is horizontal. Of course, I'm not drawing very accurately. However, these tangent lines are supposed to be horizontal. So let's just redraw this here. So these 3 points that I highlighted are called turning points of a curve, where the curve turns. So the curve was increasing before and now it's decreasing, for example. Here it was decreasing and then after the point it became increasing again, and so on and so forth. Another name for turning points is stationary points. So turning points or stationary points are points where the behavior of the curve changes from increasing to decreasing or vice versa. And they have a very important characteristic, which is that the gradient at these points is 0. So by definition, a turning point must always have 0 gradient. And in the previous video, we said that y dash is equivalent to m. Y dash is an expression for the gradient, and if we substitute x for a particular value, we get m, which is the gradient at this point. So in order to get m, we always need to get y dash first. And all of what I said up to now leads us to a very simple rule that for any turning point, y dash must equal 0, because the gradient is 0 and y dash represents the gradient. So for any turning point, the simple rule is that y dash must be set to 0. Of course, y dash is the derivative of y, and we learned how to obtain that in the previous video. So for example, for this equation, y dash equals 3x squared minus 12. So therefore, this expression here will be set to 0, and we're going to solve for x. So we can take the 12 to the other side. So we have 3x squared equals 12. Next, we can divide by 3 on both sides. So x squared equals 4. So x is either equal to positive 2 or x is equal to negative 2. Now, we want the coordinates of the turning points. So we know that the x coordinate in this case is 2 or negative 2. But we still need to get the y coordinate, and we do that by substituting back into this expression. So let's write this down. We have y equals x power 3 minus 12x. So to get the values of y, first we put x equal 2. So we get 8 minus 24, and this is equal to negative 16. And then we put x equals negative 2. So we get negative 8 plus 24, and that gives us positive 16. So when x equals positive 2, y equals negative 16. And when x equals negative 2, y equals positive 16. And of course, this is our final answer. So negative 2 and 16 is correct, and 2 and negative 16 is also correct. Calculate the x values of the turning points of y equals 9 plus 9x minus x squared minus x power 3. Show all your working and give your answers correct to 2 decimal places. So first of all, we said that whenever we have a turning point, this is equal to y dash, or we set y dash equal to 0. So first we need to obtain an expression for y dash. This is 0 plus 9 minus 2x minus 3x power 2. I simply differentiated this expression there. So we get this expression for y dash, which is negative 3x squared minus 2x plus 9. I'm simply rearranging the expression to go from highest power to the lower powers in descending order. Now we have a quadratic equation and we want to set that equal to 0. So we need to solve this quadratic equation. One thing we can do is just simply apply the quadratic formula. So in this case, a equals negative 3, b equals negative 2, and c equals positive 9. We can just apply x equals minus b plus minus root b squared minus 4ac all over 2a. So the b here is negative 2, and the a is negative 3, and the c is positive 9, and this a here is negative 3 as well. So we get the following expression. So x equals negative negative 2, which is positive 2, plus minus root negative 2 squared. So we have negative 2 squared, which is 4. And then minus 4 times negative 3, or negative 4 times negative 3 is positive 12. 12 times 9 gives us 108. So we have plus 108. And all of this is divided by 2 times negative 3, which is negative 6. So we have 2 plus minus root of 112 divided by negative 6. They want the answer to 2 decimal places. So let's first evaluate root 112. This is equal to 10.583. So we have, let's just split it into 2 equations now. We have 2 plus 10.583. So 2 plus 10.583 divided by negative 6. And 2 minus 10.583 divided by negative 6 again. So for the first one, we have 2 plus 10.583, which is 12.583, divided by negative 6. This gives us negative 2.097, which is basically negative 2.10. And for the second one, we have 2 minus 10.583. And then we divide the answer by negative 6. We get 1.43. Finally, so we don't need to get the y values here because they just want the x values. So we're just going to write these down as our final answers, negative 2.10 and positive 1.43. And these are the correct final answers. You can see them right there in the marking scheme. Find the coordinates of the two stationary points of y equals x power 3 minus 1.5 x power 2 plus 1. Again, quickly now, we know that stationary points have the rule or follow the rule of y dash equals 0. So let's begin by getting y dash. Y dash equals 3x squared minus 3x plus 0, so we can just ignore that. And this is equal to 0. Now we can take we can take 3x as a common factor. We are left with x minus 1, and this is equal to 0. So either x equals 0 or 3x equals 0, so x equals 0, or x minus 1 equals 0, and this tells us that x equals 1. Finally, we plug these values into the original equation of the curve. So when x equals 0, you just put 0 here and 0 here, so y equals 1. When x equals 1, you have here 1 minus 1.5 plus 1, so y equals 0.5. So you have 0, 1 as a first point and 1, half as a second point. 0, 1, and 1, comma, half. These are the 2 points. And these are the correct answers here. The equation of a curve is y equals x power 4 minus 8x power 2 plus 5. Find the derivative dy by dx of y equals, and we have the same equation written again. So the derivative simply will be 4x power 3 minus 16x plus 0. This is y dash, of course. And we can remove the 0, so we can just write a final answer of y dash. Of course, y dash is the same as dy by dx. So these are the same exact thing. Here they want it written as dy by dx. So this doesn't really matter. We can follow their notation. Dy by dx equals 4x power 3 minus 16x. Find the coordinates of the 3 turning points. You must show all your working. So we said before that whenever we see the word turning points, we remember the basic rule that says y dash equals 0. So y dash is the expression we obtained in A. So we have 4x power 3 minus 16x equals 0. We can take 4x as a common factor. We are left with x power 2 minus 4 equals 0. Of course, this can be further factorized using difference of two squares. So we have x plus 2 and x minus 2. Now we have 3 terms multiplied by each other, giving us 0. So either this is 0, which means x is 0, or this is 0, which tells us that x is negative 2, or this here is 0, which tells us that x is 2. So the x coordinates of the 3 points are 0, negative 2, and positive 2. To get the y coordinates, we must go back to the original expression, and we must plug x as 0, and then as 2, and then as negative 2. So for 0, we get 0 here and 0 here. So 0 plus 0 plus 5, y equals to 5. For 2, we get 16 minus 8 times 2 squared. So 8 times 4, which is 32, plus 5. So negative 16 plus 5. This gives us y equals negative 11. For x equals negative 2, you can smartly observe that these are even powers. So whether x is 2 or negative 2, we're going to get the exact same answer because we have even powers. So again, this will be 16. Again, this will be 4. 4 times 8 is 32. So minus 32 plus 5. It's the exact same answer again. So when x is 0, we have y equals 5. When x is negative 2, we have negative 11. And when x is positive 2, we have positive 11. In C, we are asked to determine which one of these turning points is a maximum and to justify the answer. So how do we figure out whether it's a maximum or a minimum? So you should understand that y double dash, which is like the derivative of the derivative, gives us the concavity of the curve. So we have two scenarios. So when y double dash is positive, we have a concave up curve, or more simplistically, a smiling curve like this. And when y double dash is negative, we have a frowning curve, an upset curve or something. More formally, it's called a concave down curve, but I like to remember them as positive equals smiling, negative equals frowning. So if it's a smiling curve, the turning point is at the bottom, so this is a minimum. If it's a frowning curve, the turning point is at the top, so this is a maximum. So we want which one is the maximum. We want to figure out which one of these is a maximum. So we're looking at the turning point that makes y double dash negative. So let's first calculate y double dash. This here, of course, is y dash. So if we differentiate this again, we get y double dash. So y double dash will be the derivative of 4x power 3, which is 12x power 2, and then minus 16. I simply differentiated the expression that we got for y dash or for dy by dx. I differentiated this in order to get the expression for y double dash. Now, if I put 2 or negative 2 here, I get a negative. So if we put 0, we get a negative as well. Excuse me, I said something wrong. So let's just try to plug 0 and 2 and negative 2 and see what happens. So we have x equals 0, we have x equals 2, we have x equals negative 2. Let's just plug and see what happens with y double dash. So for y double dash here, if you put 0, you get 0 minus 16, and that gives us a negative value, negative 16. So this is a maximum. If we put 2 here, 12 times 2 power 2, so this is 12 times 4, so this is 48. 48 minus 16 gives us 32. So 32 is positive, so positive equals minimum. So this is what I want you to understand. Positive equals minimum, and negative equals maximum. So when y double dash is negative, it's a maximum. When y double dash is positive, it's a minimum. Also for x equals negative 2, we also get 48 here. So again, y double dash is going to equal positive 32, and that's also a minimum. So which one of these gives us a maximum? The only one that gives us a maximum is the one that has x equals 0. So the turning point that we want is 0, 5. This is the point where y double dash is negative. So therefore, this is the maximum point. Now let's check the marking scheme. So for A, we got the same expression for x power 3 minus 16x. For B, we got these 3 points correctly, and we correctly chose 0, 5 as the maximum point. A curve has equation y equals x power 3 plus ax plus b. The stationary points of the curve have coordinates 2k and negative 2, 10 minus k. Work out the value of a, the value of b, and the value of k. So this is a more challenging problem. Again, we have stationary points, so we want to get y dash and set it to 0. So y dash is equal to 3x power 2 plus a, and then b becomes 0. So y dash is equal to 3x power 2 plus a, and we want to set this to 0. And it is 0 at the turning points, which are 2 and negative 2. So let's just try to plug in x equals 2 here. So y dash equals 3 times 2 squared plus a, and this is equal to 0. So therefore, we can say that 3 times 4, which is 12, plus a equals 0, and therefore a is negative 12. Now that we have a, in order to get b and k, we can simply plug in the values into the original equation and try to figure out the values of b and k. So what we're going to do is, first we're going to rewrite the equation. So we have y equals x power 3 minus 12x plus b. And we know that when x is 2, y is k. So we can first plug x equals 2 into the original equation. We get k for y first. So let's just write k first, because y is equal to k. So k equals 8 minus 24 plus b. 8 minus 24 is negative 16. So k equals negative 16 plus b. And then for the second point, we are going to plug x equal negative 2. And the y will be 10 minus k. I'm using the coordinates of the given points here. So this was the first point, and this is the second point. So 10 minus k equals, and then we plug x as -2, so we get -8 plus 24 plus b. So 10 minus k equals positive 16 plus b. You can use any method of solving two simultaneous equations. Of course, I can just substitute here. I'm going to say 10 minus, and then instead of k, I'm just going to write this expression here. So 10 minus -16 plus b equals 16 plus b. We can distribute the negative sign, so we get 10 plus 16 minus b equals 16 plus b. Let's take everything. Let's take the b to the other side, so we get 2b on the right. And let's take the 16 here, so we get 10 plus 16 minus 16. So 10 equals 2b, and b equals 5. So far we have a equals -12, and b equals 5. Now we need to get the k. Of course, we can just use any expression that relates k and b. We can maybe just use this expression here. So -16 plus 5, k equals -11. Having obtained them, we can just write them down in the blank spaces below. We have -12 for a, we have 5 for b, and we have -11 for k. So -12 and 5 and -11 are the correct answers here. F of x equals x power 3 minus 3x squared minus 4. Find the gradient of the graph of y equals f of x, where x equals 1. So this is similar to what we did in the previous video, where we said that gradient can be obtained, m can be obtained from y dash. So y dash here equals 3x squared minus 6x. And then we plug 1 into the x's of the y dash. So m equals 3 times 1 minus, or 3 times 1 squared minus 6 times 1. So this is basically 3 minus 6. And the gradient is -3. In B, we are asked to find the coordinates of the turning points of the graph. So the turning points have the property of y dash equals 0. So we're just going to set our y dash to 0. So 3x squared minus 6x equals 0. And 3x times x minus 2 equals 0. So therefore, either x equals 0 from this, or x equals 2. Having obtained the x values, we go back to the original equation and we plug x equals 0 and x equals 2. When x is 0, y is simply 0 minus 0 minus 4, so -4. When x is 2, y would be 8, and then minus 3 times 2 squared, so 3 times 4, so 12, and then minus 4, so y equals -8. So the coordinates of the turning point will be 0 and -4, 2 and -8. Finally, in C, we are asked to sketch the graph of y equals f of x. So we will use the turning points to try to figure out what the graph looks like. So y equals f of x has the equation y equals x power 3 minus 3x squared minus 4. When x is 1, the gradient is positive. That's one piece of information we know. Excuse me, so when x is 1, the gradient is negative. It's -3. And then we also know that the turning points are at 0, -4, and 2, -8. So let's just plug them in here. So we have a turning point here at 0, -4, and we have another turning point at 2, -8. So we have another point here. We want to know what this curve will look like. Of course, this is a cubic curve, so it usually has an S shape, in a sense, looks something like this. But anyway, in order to figure out how to draw the curve, we need to figure out whether these points are maxima or minima. And the way to do that is to get y double dash, like we said before. So if we get y double dash from here by differentiating this again, we can say that y double dash is equal to 6x minus 6. So when x equals 0, y double dash is negative 6. When x equals 2, I'm using the coordinates of the turning point. So when x equals 2, y double dash is equal to positive 6. So this here is negative, so it's a maximum, and this here is positive, so it's a minimum. So we know that at 0, we have a maximum. When x equals 0, we have a maximum, so it looks something like this. And at x equals 2, we have a minimum, so it looks something like this. Once you have these shapes here, it's very easy to draw the rest of the curve. You just extend this like this, and you join these together like this, and you can continue the curve upwards as such. So this is what the curve is going to look like. So -3 is correct for A, 0, -4, and 2, -8 are correct for B, and our sketch looks very similar to their sketch for C. So for C, you get 2 points if your sketch satisfies the following properties. You want the maximum to be on negative y-axis, which is this point, which is on the y-axis at -4. And you want the minimum in the correct quadrant and extends into the first quadrant. So basically, this here is correct as well. So we satisfied the 2 marks, the requirements for the 2 marks, and this is the correct drawing. Find the coordinates of the 2 stationary points on the graph of y equals x power 6 minus 6x power 5. You must show all your working. So again, this is a stationary point problem. So we have to write here y dash equals 0. And we have to differentiate. So y dash equals 6x power 5 minus 30x power 4. And this is equal to 0. So let's take 6 as a common factor between 6 and 30. And let's take x power 4 as a common factor as well. So we are left with x minus 5 equals 0. So either x equals 0 from this, or from here we have x equals 5. And then we have to go back and plug them into this equation. So when x equals 0, y, of course, will equal 0 as well. When x equals 5, we need the calculator here to figure this out. So 5 power 6 minus 6 times 5 power 5. So this gives us y equals negative 3,125. So the coordinates of the turning points will be 0, 0, and 5, negative 3,125. And these are the correct coordinates for the turning points. Differentiate x power 3 minus 4x power 2 minus 3x. So this becomes 3x power 2 minus 8x minus 3. The curve has equation y equals, and it's the same exact expression as A. Work out the coordinates of the 2 stationary points and show all your working. So we already got y dash. So y dash equals 3x squared minus 8x minus 3. And this is equal to 0. And we want to figure out the values of x. So A equals 3, B equals negative 8, C equals negative 3. You cannot just use the calculator to evaluate A, B, and C because they said show all your working. So you have to use either factorization or the quadratic formula, whichever one you choose. So I did a similar problem with the quadratic formula. So I'm just going to use factorization for this one. I changed my mind here. I'm not going to use the quadratic formula again because we already saw an example of that in this video. Let's use factorization instead. So I want 2 numbers that when multiplied, give me the product of these 2 numbers as well. So A times B equals 9. and then their difference, because this is a minus here, so their difference has to be -8. So what two numbers would multiply to give 9 and subtract to give -8? Of course, these numbers are 1 and 9. 1 minus 9 is -8, and 1 times 9 equals 9 as well. So we have 3x plus 1 and 3x minus 9 equals 0. Of course, we have to simplify if possible. So 3 and 9, they simplify together. So this becomes 1x minus 3. So the final answer for factorization here would be 3x plus 1, x minus 3 equals 0. So either x equals -1/3 or x equals +3. Now, in order to get the y coordinates, we have to plug these values into the original equation. So we have to go back to the original equation and plug x once as +3 and once as -1/3. And we have to get y in each case. You can use your calculator. So for the first one, we have 3 power 3 minus bracket 4 times 3 power 2 close bracket minus 3 times 3 again. So y is -18 for the first one. And then for the second one, you would have to repeat the process, but with -1/3. So we have open bracket, insert fraction, -1 divided by 3, close bracket, and then raised to the power of 3. And then minus open bracket 4 times insert fraction. You have -1/3 again. And this is raised to the power of 2. So I would have to insert an additional bracket before the fraction so as to have the power 2 only affecting the fraction, not the 4 as well. So this is to the power of 2. And then finally, minus open bracket 3 times fraction, -1 divided by 3. I'm just telling you what I'm writing on the calculator so that you can follow on yours. And after evaluating these things, I got a final answer of 14/27. So the coordinates of the turning point here are 3, -18 and -1/3, 14/27. This would be the final answer to this problem. Finally, in C, we want to determine whether each stationary point is a maximum or a minimum and to show all our working. We said before that to get the nature of the stationary point, the type of stationary point that we have to get y double dash. So for y double dash, we have 6x minus 8. I'm differentiating the red expression, the y dash expression. So 3x squared becomes 6x and minus 8x becomes minus 8. And now we plug once x equals 3 and once x equals -1/3. So when x equals 3, y double dash is equal to +10. And when x equals -1/3, y double dash equals -10, because here you get -2. -2 minus 8 is -10. So for the first point, y double dash is positive. Remember, y double dash can be positive or negative. If it's positive, we have a smiling curve, so we have minimum. If it's negative, we have a frowning curve, so we have maximum. So for the positive value of y double dash, this is a minimum. For the negative value, this is a maximum. So therefore, the point that corresponds to 3, which is basically 3 and -18, is a minimum. And for the maximum, -1/3, positive 14/27, this is a maximum point. So it seems that our answers are correct. 3 and negative 18 is a minimum. Negative 1 over 3 and 14 over 27 is a maximum. So for the final question or problem in this video, we have a diagram that shows the sketch of a graph of y equals 4x power 3 minus x power 4. The graph crosses the x-axis at the origin and at the point A. The point B is a maximum point. Differentiate 4x power 3 minus x power 4. So here we're just asked to differentiate. This becomes 12x power 2 minus 4x power 3. Find the coordinates of B. So the trick here is that they did not say the word stationary point or turning point. However, they did say maximum point, and it looks like it's a maximum point from the curve. So you can tell here that the tangent will have zero slope. It will be a horizontal tangent. So y dash equals 0 at this point. And we can apply this logic to question B, because y dash equals 12x squared minus 4x power 3, which is equal to 0. So if we solve this expression, we can get the value of x. So 4x power 2 taken out as a common factor leaves us with 3 minus x, and this is equal to 0. So either x equals 0 or x equals 3. Of course, from the graph, we can obviously tell that B cannot have x equals 0, must have x equals 3. And this is actually another type of turning point called an inflection point, but this is not really within your curriculum at the moment. So let's just ignore that for now. We want the coordinate of B. So the x coordinate is 3, and we can plug it into the equation of the curve to get the y coordinate. So if x equals 3, y equals 4 times 3 power 3 minus 3 power 4. You can either use your calculator or you can just take x power 3 as a common factor. You would have 4 minus x. So x power 3 is 27. 4 minus x is basically 1. So the answer will be 27. Or you can just use the calculator to figure this out, no problem. So the coordinates of B will be 3 and 27. We'll just write that down. 3 and 27 right there. And then finally, for question C, we want to find the gradient of the graph at A. Let me just circle the correct final answers. So for C, we want to find the gradient of the graph at A, like I said. So this is point A here, and we know that the gradient is obtained from y dash. So y dash equals 12x squared minus 4x power 3. But we need to find the value of x to plug into this y dash. What is the value of x at A? So this is obtained from using logic. So since here at A, y equals 0, we can plug here y equals 0 and find the value of x. So let me just write it away. I'm going to write it further away, so just use some space. So y equals 4x power 3 minus x power 4, and we just said that y is equal to 0. You can factorize this. You can take x power 3 as a common factor, and you are left with 4 minus x, and this is equal to 0 here. So either x equals 0 or x equals 4. Obviously, point A, like with using the same logic as point B, we can tell here that point A has a value of x equals 4, not x equals 0. So now that we have the x value, we can just plug it into y dash in order to get the slope or the gradient. So 12 times 4 squared minus 4 times 4 power 3. This is a complicated expression. I'm just going to simplify it by taking 4x power 2 as a common factor. And we have 3 minus x like this. And I'm going to plug the x as 4 now. So 4 times 4 power 2, 64. 3 minus 4 is negative 1. So the gradient is negative 64. So therefore, the answer to C is m equals negative 64. The trick I just did with the factorization is not necessary. You can just use your calculator. I just find it faster sometimes to factorize to make the calculation easier for myself. So we have 12x power 2 minus 4x power 3, and then we have 3 comma 27, and then we have negative 64 as a final answer. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.